Okay, let's go ahead and get started. I thought to start with, we would take a minute and kind of talk through Chapter 6 and try and identify what's important, what's not important. And then we'll try and take any questions that you may have had from last period. And then after that, we're going to try and work through this handout. For the remote students, we've put this handout up on TCE. You should be able to get access to it, look at it, or print it out. It will be on the overhead as we kind of talk down through it. The conference, the Industrial Advisory Board meeting for the eDesign Center is still going on. It fired up at 7 o'clock this morning. I was there until a little bit before 9. I dashed over, taught my 172 class. I will be teaching, hopefully, this class and answering any questions. As soon as it's over, I have to rush back to the Provo Marriott to finish the Industrial Advisory Board meeting. So the chance of me having office hours is kind of slim to none today. But my life should return to normal, somewhat normal, on Friday. Right? So I apologize for kind of being out of reach for a couple of days, but we'll be back in the saddle on Friday. So if you have your books with you, you can flip to them and make marks in them or something. If you don't have them, please kind of write down these section numbers as we go through and talk about it. So Chapter 6 begins with 6.1, which is an introduction. That is certainly worth reading. Okay. 6.2 gets into curved entities. And I think all of us should take a minute or two and look at this 6.2 section, because what the author has attempted to do, they've attempted to They've attempted to identify what kind of input, click an answer, and then just hide it away. They've attempted to identify what kind of input your CAD system is expecting, depending on whether it's a line, a circle, an arc, or whatever. And that's just a good review. It's not something that is earth-shattering. It shouldn't be too new. It shouldn't be new at all. But it's worth kind of your time and effort in just reviewing that. They drop from that into a 6.3 where they get into curve representations. And the 6.3 section is worth your time reading. Okay? It goes through kind of a basic understanding of a parametric curve, which we covered last time. It talks a little bit about finding the slope or the instantaneous change on the curve and how that's all done. So that's a section worth reading. It goes from that to 6.4, analytic, which is, again, a very short paragraph. It's worth reading. And then it drops into lines. And so where you ought to try and focus more of your time or interest is really in 6.5, where it talks about lines. We spent quite a bit of time last period talking about lines. So that's certainly worth reading. From there, it goes into circles, 6.6. I wouldn't spend a whole lot of time there. It goes through and explains the mathematics of a parametric circle. And yes, the CAD system represents circles with a parametric definition, but we're not testing, we're not going to focus on that. We're going to skip over circles. We're going to skip over the next 2 or 3 sections. So we're going to skip over ellipses. We're going to skip over the parabolas. We're going to skip over the hyperbolas. We're going to skip over the conics. And then we want to get back to 6.11, which is synthetic curves. Again, just read this section. Don't try and dive into it, just read it. And then it goes from that to 6.12, which is Hermite splines. That section, I would take a minute to kind of gloss over and look at it. We're going to talk a little bit today about Hermite splines. Then 6.14 is B-splines. I would just kind of look through it, speed read it. It's not where you want to kind of spend a ton of time. Did I skip one? Where's the Bezier?
Bezier curve, 613.
Too many pages. 613, you definitely want to spend, so lines, that section, and Bezier is where you want to spend most of your time trying to sort through and understand. After the B-spline, it gets into a discussion of nerves. And again, you ought to make a kind of a quick read of that. Doesn't have nerves. It has B-splines. What's that?
What section are we in right now?
So 614 is B-splines. That should be a quick read. From that, it goes into curve manipulations. And in that section, you ought to just kind of do a quick read of it. And 616 is tutorials, and I wouldn't spend any time in tutorials, and that takes you to the end of the section. So your main focus in reading ought to be lines and Bezier. There's a couple others that are worth a quick read, and then there's a bunch. Circle, parabola, hyperbola, a bunch of those you skip over. Okay, questions from the last time? Questions?
I was trying to do the seventh order Bernstein matrix.
Okay.
How do you do the internals?
Okay. So that's a very good question. How do you do the internals of this MBE matrix? What was the magic that we did? I think that will come clear from the example that we're going to work through. So if it's not clear at the end of the period, absolutely raise your hand, ask the question. We'll make sure that we kind of take a deeper dive on that. But I'm hoping this handout will help kind of explain that. Other questions? Yes.
How do you use a Bezier curve? Like, for example, is it just defining points in the CAD program, or is it some sort of equation that you go in to build that line, or is it just?
Okay, another really good question. In the CAD system, pretty much anymore, the only thing that we really kind of play with are either splines, which are kind of the B-spline formulation, or we play with nerves, the non-rational uniform B-spline. We play either with B-splines or nerves. Okay? At the heart of those, the mathematical definition is a Bezier. And so they've taken the capability of the Bezier, which we talked last time about the control net of a Bezier being a linear interpolation of 4 points if you're doing cubic. A B-spline or a nerve has many Bezier segments buried in it so that you can actually kind of sign your name with a B-spline or with a NURB, either one of those curves. And when you're on the CAD system and you reach up and say, I want to do kind of a free-form curve, and you click on it, you can either put in points on the curve, or you can put in points that are the control net of the curve. Have you seen that? Okay. So when you're doing that, you're typically building a B-spline or a NURB. You're not building a Bezier unless you're just giving it 4 points. If you're giving it lots of points, then typically it's a multi-segment Bezier that we call a B-spline or we call a NURB. There's little bitty Bezier curves embedded in those other definitions. Okay, so if you look at the handout, the very first thing that we do is we've kind of laid out of the book the representation of a Bezier, the representation of a B-spline, the representation of a NURB, and basically we immediately go and say, we're going to look at an example of a cubic Bezier. So from last time, we just wrote the expansion from that formula above. We wrote the expansion. So it's a summation, and it says, tell me what the first point is. Well, the first point is P naught, okay? And tell me what the first blending function is. Well, if you do that expansion that we did last time, it's 1 minus u cubed. The next term is going to be 3 times the next point, or the point times 3, u, 1 minus u squared, so the next blending function. Okay. Again, third point, P2, times 3 u squared minus 1 minus u, plus the fourth point, u, and all of that is defined where u is between 0 and 1. So that's from last time we did that. We derived it. We showed last time how you could separate this all out. Okay, so where did this, where did the 1 minus u cubed come from? Well, it's our first blending function. If you expand it, where do these coefficients come from? Well, we said that the coefficients come from Pascal's triangle, right? So we know that Pascal's triangle for a cubic expansion of coefficients, we get a 1, 3, 1, 3, 1, and we vary the signs. So the first sign is positive, negative, positive, negative. Okay. So we get that. The question that was asked earlier, where do we get this? Well, this is from 3u, 1 minus u. How do we expand 1 minus u? Well, we go to the quadratic expansion. The quadratic expansion is 1, 2, 1. But we have this 3 out front, and so we can just multiply 3 and the u into that, and so we end up with 3u minus 6u squared plus 3u cubed. Okay. How do we get this term down here? Well, we look at the 1 minus u. What are the coefficients of that? Well, that comes from the linear Pascal's triangle. And
you say the presenter's connection is down, sit tight. The left front.
not plugged in. It's wireless. So we can make that.